Welcome to the second part of the lecture where we talk about footprints. Footprints are one of the methodologies or ways in which we can also quantify the challenges of the linear economy. Only when we can sort of quantify the challenges of linear economy, we can think about exactly the types of mitigation strategies that we can plan. So when we talk about footprints, environmental footprint is an umbrella term that is proposed by Professor Hoekstra and Wiedemann. The article that is published in Science is added as a reading material, so I highly encourage you to read it in full. Environmental footprint is sort of an umbrella term. It includes all sorts of footprint: carbon, material, water, ecological, etc. So in this course moving forward, we are going to see in detail about three footprints: carbon, material, and water. But environmental footprint, it literally tries to quantify the total human pressure on the natural environment. So what we try to do with quantification, one of the strategies is to improve the resource efficiency. What is resource efficiency? Resource efficiency means that we try to have a smaller footprint per unit of product. But how we quantify the footprints per unit of product needs to be very carefully considered, because for instance, let's take a beverage company. The most of the footprints, almost 99% of their footprints, are actually indirect. What is indirect we are going to see in the next slide. But ignoring indirect footprints is a problem. And the other thing that we have to emphasize is that footprints are connected in complex ways. So for instance, we try to reduce the carbon footprint. We try to move towards using a lot of biomass. You can imagine that this puts pressure on the ecological footprints, that is the land area that we are trying to use, and also on the water footprint, the amount of water we need to use for it. So the footprints are not individual entities, but they are connected to each other in complicated ways. So we discussed about indirect footprints in the last slide. See the figure to the right here. As you could see, the product's footprint is not just its direct or operational footprint, that is, the footprint that is counted during its production in a particular company, but also you have to take into account the indirect footprint, the footprint of a product along its whole supply chain. So let's say you want to produce a product, a magnet or a battery. You have to procure so much of raw materials from another geographic location, because all raw materials are not available in one particular geographic location. Probably you have to procure different raw materials from multiple different geographic locations. So you have to take into account the footprints of those materials along the whole supply chain. So a product's total footprint is the sum of its own operational footprint that's happening in a particular company, plus the indirect footprint that has to be counted along its whole supply chain. To the left, you see this globe-like figure which quantifies different sorts of footprints and the sustainable limits. One thing that you have to notice here is that there is a lot of debate in its ambiguity, and a lot of it is subjective. Because the sustainability is going to be built only on a consensus. Let's say we have to have a 2 degrees Celsius from GMST from the pre-industrial level is a consensus that we have built over times. So take one particular footprint into account that is given here, the carbon footprint, which is given in gigaton carbon dioxide equivalents per year. There is a debate of whether should we give it in equivalents per year or a summation of CO2 emitted over a long period of time from the after the post-industrial level. So this is a debate that is going on, but we have to recognize that with a lot of variations and ambiguities, a lot of the sustainable limits that has been set has been breached. Thus far, we saw the behavior of individual as well as communities translating into footprints. And then the question comes, if the resources are limited, then what is the fair share? If you are transgressing the boundaries, then what actually is the fair share? And the question of social equity comes in, according to Professor Hoekstra. So if we take the ecological footprint of the globe, it's 2.7 versus the ecological footprint is 7.2, that of the US. The water footprint is twice bigger, the carbon footprint is 5.8 times bigger. So he brings in the question of social equity and what is the fair share to each and every individual in the planet, also that of the nations. But you have to also take into account that you have to sort of apply this spatial resolution not just between, let's say, one country and another, but also within the country. Within the country, disparities exist in terms of who contributes to most footprint. Then comes the question of what is called as international externalization and carbon leakage. The word looks complex, international externalization, but it is very simple to understand. So for instance, the UK's carbon footprint, 40% of it lies not in the UK but elsewhere, which means that the burden of production, or let's say the fact of production, has shifted elsewhere than in the developed countries. So for instance, one of the critiques they lay is that of carbon leakage, Kyoto Protocol targeted the emissions in individual countries and tried to control the agreed partners to control their own emissions. But if you see, the reality is that the production has shifted a lot to the southern countries, which simply means that their emissions are not taken into account. That doesn't come into the binding agreement, and that is what they call as the carbon leakage. Third important point they raise is that we can have policies to improve the resource efficiency, but that doesn't really translate into the expected savings in terms of footprints or planetary boundaries. We are going to discuss in detail about rebound effect, but what they are in fact saying is that not just improving the efficiency of devices and products, but there is a need for a change in consumption pattern to actually move towards sustainable footprints. So we are going to end this part of the footprint lecture with Professor Hoekstra's document. They propose 5 different pathways in which we can have reduced footprints. So you have to read the reading material. I will quiz you on it later. So what are the 5 different pathways that Professor Hoekstra is proposing? Please do read the reading material. Moving on to water footprint. Water footprint is basically a measure of human appropriation of freshwater resources. It could be either green water footprint, which is basically the volume of rainwater that is consumed and evaporated during, let's say, crop production. And it could be the blue water footprint, which is essentially a consumptive measure, in the sense that it could be either the water that is embodied in the produce, and you produce a product and the water that is embodied in that, or the blue water that is the fresh water that is evaporated, or the ones that you consume during a scarce period but comes back in the abundant period but it is essentially consumed, or the one that escapes from your catchment area and then goes somewhere else than the one that you're producing. And then there is the gray water footprint, which is essentially a measure of groundwater pollution, the amount of water that you need to dilute the pollutant so that it essentially becomes harmless. So that is the gray water footprint. And you can measure the water footprint of various different things. It can be that of a product, consumer, it can be that of a nation, it can be that of the whole planet, etc. So there are so many ways to measure the water footprint. Also, similar to the other footprints, water footprint also has this quality where 1/5 of it is embodied in international trade. Basically, you could see from the left side of the slide a huge international dependency of many different products and that are flowing into, for example, the European Union. A lot of it is embodied in the oil crops, for instance, the soya bean. And the need for measuring water footprint is also that we see how unsustainable or how much of scarcity that exists. Basically, if we break it down into spatio-temporal pattern, that is not just for the geographical area, but also periods, the periods of scarcity, periods of drought, and periods of over-availability. We see almost 71% of human population experiences acute scarcity at least in one point of time in a year. And that is reflected in the graph in the right hand side. One thing you have to also take into account is the way the scarcity is calculated is basically the ratio between the water footprint, here it is blue water, it could be any water, to that of the maximum available water that is there. So that is the actual measure of scarcity of that particular water. Once we understand that acute scarcity exists, which means we could also plan mitigation strategies such as putting water footprint caps, etc. Before moving on to the material footprint, let me ask you a question. Which country has the highest share of their water footprint coming from industrial production? The options are United States, Chile, China, Belgium. Take a moment to think about the answer. I'll tell you the answer. It's Belgium. So Belgium has the highest share that's coming from industrial production. Anyways, that's an interesting trivia. So what I would encourage you to do is to read page number 79 and 80 from the Water Footprint Assessment Manual. Basically, I talked about the scarcity being the ratio of water footprint in total to that of the water that is available. So they give you a method of calculating the availability. So please go and check it out. I might ask you in quiz when we actually have a one-to-one chat. So coming to the carbon footprint, this is one of the famous footprints, and I think you could have seen it also in other lectures, so I would keep it brief. So it is a measure of the exclusive total amount of carbon dioxide emissions that is both directly and indirectly related to the products or an activity, as we saw with the other footprints as well. So according to the Kyoto Protocol, you just don't have to take into account only the carbon dioxide, but also the other gases which have a global warming potential, such as methane, nitrous oxides, and fluorinated gases. So the way it is measured is using the CO2 equivalence. That is, for instance, as it's given here, 1 ton of methane is equal to that of 34 tons of the CO2. So every greenhouse gases can be translated into its own equivalent of CO2. And the VUB, the Freie Universität, have made their calculations of carbon footprint, and it's available as data, and they go through the methodologies and different categories as well. So coming to the gigaton gap, as you could see that we have to sort of drastically reduce the emissions to reach an acceptable the warming of 1.5 degrees Celsius, or to limit at 1.5 degrees Celsius. So Belgium has, for instance, 20 ton CO2 equivalents per year. So you could see that a lot of reduction is needed here. And there are multiple different articles and research has been done on carbon dioxide footprint. You can see that it is measuring across different sectors. It's measured across countries, it's measured across products, so or like geographical entities such as universities. So there is a lot of data. I will add 1 or 2 important reading notes associated with the carbon footprint, but we will now move on to the material footprint. Let's get into the discussion of material footprint. The carbon footprint has been existing and debated for a long time, but material footprint is something that was introduced very recently into the literature in 2012, if I'm right. So the first question to ask ourselves is, why would you need such an indicator? Why would we need to talk about the material footprint? So the authors of this study point out to this very interesting reason. So resource productivity is rather the headline indicator that is being used by the European Union and the UN Environmental Panel and so on and so forth. What does resource productivity means? It's a ratio between the GDP of a nation state and that of DMC. What is DMC? DMC is domestic material consumption. So the material that is directly used by the particular territory that we are talking about. So it's the raw materials that you extract from that particular territory plus its physical imports minus its physical exports. But the important thing to notice here is that the DMC does not include the upstream raw materials related to the import and exports operating outside of the focal economy, the economy that is in focus, and the ones that are imported from outside, especially the upstream ones, are not taken into account. So the people who put forward material footprint want to correct this particular aspect. So what do they propose? They propose this equation for material footprint. They say that it is the sum of the domestic extraction, as we talked about, and that of RME imports minus RME exports. What is RME? RME is raw material equivalence of the imported or the exported products. So basically, it is the extraction that you need to provide a particular product. So imagine you want to get a magnet that is consisting of rare earths. You just simply don't go into a mine, you ore and you pick out the rare earth that you want to actually use for your magnets. For taking the neodymium and the praseodymium that you get in your magnets that are used in your loudspeaker that you are hearing right now, didn't come really simply from an ore and jump out and then we could extract a particular metal easily. There are a lot of mine tailings, there are other metals that are associated with these ores. So as you could imagine, the raw material equivalent means that you have to take into account not just that metal that you use in the products, but everything else that is associated with it. So the material footprint takes into account all these things. So see the graph in the slide. This is one of the most important and fascinating graphs I've seen. Basically, see the GDP over years, it's growing all the time. And notice particularly for the US and the UK, you see the quantity DMC is going down over a period of time, right? The claim from EU especially is that you have achieved a sort of a decoupling, that is, there is an increase in resource productivity, there is growth in terms of GDP without a lot of material consumption, which is reflected by a decrease in the DMC. If this claim is true, then it means that you can have constant economic growth. You don't need to worry about growth at all, and the consumption is not high anyways. But is this true? Was what the researchers tried to challenge using material footprint. You see, when you put the material footprint, when you graph the material footprint out, the story completely changes. That is, it is not going down. On the contrary, it is increasing together with the GDP. What does that mean? Once you take into account the indirect flows in the materials, that is, the ones that you need to extract to be used in a product into account, it simply paints a completely different picture. So much so that the 41% of the total global resource extraction was completely associated with international trade flows. Basically, a lot of it is associated with trade. And interestingly enough, the material, a lot of it is not even physically moving from one place to other place. So as I explained to you in the previous slide, if you extract a metal to be used in a product, the ore tailings remain in the place where you extracted. So in the previous methodology with DMC, the tailings would be attributed to the footprint of the country where it was mined. But with material footprint, what they do is that they add it to the product so that you move the burden from the producing country to the consuming country. So this is really an important contribution from the material footprint researchers. So the researchers further broke down into different sectors and then compared explanatory variables, for instance, GDP per capita or domestic extraction per capita with material footprint and domestic material consumption. So they took the crops, fodders and ores and construction materials, etc. So what you see essentially is that let's take the first row and the first column. what you see for a 10% increase in GDP per capita, you have almost 6% of increase in material footprint in total, which is really correlated. And it's not the case for the DMC at all. Especially take that of construction material, the GDP per capita is truly correlated with it, whereas it is not at all explained by the domestic extraction per capita. It's almost not at all correlated. So it literally means that the production has been offshored, and the products that is being imported has a lot of embodied materials that comes with it, essentially from the upstream, as I explained in the previous slide. So to sum up, material footprint is relatively a novel indicator. It's a new indicator, and it's very interesting to see the differences between the old indicators and the new ones. And if we are to say that we have finite resources in the planet, and if you are to truly dematerialize, it is quite challenging to have it together with the growth. So we saw a lot of things, one with the planetary boundaries and one with different types of footprints. And the task for you is to summarize the real and exact challenges of the linear economy. Is it just we have to transform the take, make, dispose of linear economy by, let's say, introducing recycling, or is linear economy's challenges much more complicated with a lot of different pressures on the environment that we need to overcome, and how the pressures are interconnected to each other, and how, when we bring into the account of fairness and social equity, this can take shape. So once we have summarized all the challenges of linear economy and create a sort of list of these challenges that need to be overcome, then we pose these set of exact questions to the circular economy paradigm that we are going to see in this course, and then ask ourselves, is circular economy's paradigm able or capable to overcome these challenges? We are going to see it objectively, and we are going to see all different sides of arguments of circular economy and weigh the balances really carefully.